We are going to solve a Leetcode question which is called as maximum score of a split. In this question you are given a nums array of length n. You need to choose an index I such that it should lie between 0th index and n minus 1 index. Here, when you choose the index I, the answer you need to give is the maximum score between a valid split index. What is a split index? A split index is the difference between prefix sum and suffix min for that index. Let us now understand what is suffix min first. Suffix means if you are choosing an element, you need to tell from its next element what is the minimum value that you can find. For prefix sum, for the selected element, what will be the sum till that value. Like if you are choosing first element, the prefix sum of that first element will be 0th index sum plus first index sum, right? Let us now understand using an example how we are going to solve this. We need to return the maximum score of all the valid possible splits. Okay, so here's our example where we are given a nums input of 10 comma minus 1 3 minus 4 and minus 5, right? Let us first create a prefix sum. We have a prefix sum array here. What we are going to do is simply we are going to generate a prefix sum. First value will be 10. When we add minus 1 to 10, it will be 9. When we add 3, it will become 12. When we add minus 4, it will become 8. When we add minus 5, it will become 3. So this will be a prefix sum. Now let us calculate suffix min. Represent the minimum value after the index that you have selected. If we are selecting 0th index, if we are selecting this value 10, after this index, like from when we start from here, we need to find the minimum value between this range from minus 1 to minus 5. Here we can see the minimum is minus 5, so we will add minus 5 here. So let us add minus 5 here. Then what we are going to do is that we are going to select the first index. Now we are going to select the first index. Now we are going to see from second index till the nth index size of the nums array and try to find which is the maximum element. It's still minus 5, so it will again be minus 5, and this case will be for everything till the size of the array, because we can see the every value is minus 5 over there. The minimum is minus 5 over there, and it's in the rightmost side. That's why we are adding. So a suffix min is already also created. Now what we need to do is that we need to apply the simple formula. For score of I, what we are going to do is that we are going to do prefix sum of I minus suffix min of I. We are going to apply this formula. For score of 0, what will be our value? Prefix sum is 10 plus 5, we have 15, right? For score of 1, we have 9 minus, so it will become 5, it will be 14. So we have score 1. Let us copy this here. For score 2, we have 12. 12 plus 5 is 17. Now for score 3, we have 8 here. This will become 13. Now for score 4, we will have 3 plus 5 is 8. So out of this all values, 17 is the maximum value that we are expected to return. This is the main thing that we need to follow. Now what can happen is that I had ran into a case. Let me discuss that with you. So for case something like this, let us do a dry run. So for this case, prefix sum will be 1 comma 2, right? This will be a prefix sum, and our suffix min will be 1 comma 1. This will be a suffix min. When we try to apply the same formula here, Let us copy it. Now what will happen is that this will become 1, this will be -1, this will become 0. When we try to do it for first index, it will become something like this. This will be 2 and this will be -1. So our value will come as 1, which is wrong because we are expected to give 0. Here the condition which we need to validate is that we need to choose an index which is between 0th index and n-1. Here the only valid index will be this, so we will discard this. So this will be our maximum value, which will be 0. Let us now understand how we are going to implement this code. What we are doing is that we are storing prefix and suffix min, and we are simply calculating sum, finding minimum values. For minimum value, what we are doing is that we are traversing from right to left, and for prefix we are going from left to right. That's how the most efficient way is to solve. The overall time complexity will be big of n, space complexity will be big of 2n, because we are storing suffix as well as prefix. Here what we are doing is that I have did workaround for this. What we need to do is that we need to store the first element twice. Why? Let me tell you. So if you take this case, and try to calculate suffix min, what will happen is that you will do -5. Okay, -5 will be the maximum thing, and this will be our value. Okay, for this value it will be this, -5, for this will be this, and this will be 3. And in start we will have this also, according to the logic that we have implemented. So what we are doing is that we are going to simply add one element extra at the last, because we know last element will be always there, and we will pop this value. So we will have the exactly what we need, because we need to implement, we are not implementing normal suffix min, right? We are not finding the minimum value from that index, we are finding I plus 1th index. If we start from there, we have to look into this array. If we start from here, we need to look here. If we start from here, it's given in the question itself, this will be the minimum only. That's why we have implemented this. After that, what we are doing is that we are filling from the back. So what will happen is that this will be something like this. When we fill from back, -7 will be there, so it will look something like 3, 3, -5, -7. This will be something like this. So when we pop back, this will get removed, and when we reverse it, it will become -5, 3, 3. That's why we are reversing it here. Now we are going to find the maximum value which is possible by calculating all the possible conditions that are valid. Here I am traversing till 0 to n-1. We are simply calculating the based on the formula and storing maximum. After that, we are simply returning the maximum value. Let us now run the code. As we can see, our code is successful.